Welcome to this video on how to perform a paired sample t-test using SPSS. As before, we're going to use our diet data, and as I explained in the previous video, the way you can tell if data are paired are, for example, if you have the same individual and you have two measurements taken. So in this case, we have an individual on diet 1, we have their start weight, and then we have their end weight. This is another individual, so each of these measurements are paired up, and the same goes here for diet 2. So in order to do a paired t-test, we go to Analyze, Compare Means, Paired Sample t-test, and then what we have here is a box with two variable boxes. So you want to put the two things that you're comparing next to each other, and it just depends on the order in which you add them. Now you could also analyse diet 2, and this would look at this separately compared to diet 1, but it's a bit confusing when you look at the output. So I'm only going to show you this for now, but in the future you could potentially do a lot more tests simultaneously. So the first table you'll be used to seeing now in terms of the numbers. I would expect to see this. They should be the same number. This tells us the mean weight of the start weight of diet 1 and the end weight for diet 1. And that's useful because if we do get a significant difference, we'll know which direction it's happened in. The correlation here, so this is telling us this is very significant, and because it's quite close to 1, this means that it's very highly correlated. And what that's relating to is, for example, this person here, it looks like that they are the heaviest individual when the diet begins. They are still the heaviest individual when the diet ends. However, they have themselves lost weight. So it is important that this value is compared to this value, for example, and not necessarily other values in the analysis. So that's all that that's showing you, that our data are well correlated, they're paired up quite well. The next table, this shows you here, this 3.3 mean is actually the difference between your two means in the first table, and then these values relate to that mean. This is your actual t-test statistic, your degrees of freedom, and then here you have your p-value. So this is very significant. So you could write this as p is less than 0.001. It's very significant, or 0.001 I should say. And because it's two-tailed, this means it's been tested in both directions. Was the end weight both testing it for, was it higher or was it lower than the start weight? And we can see here by looking at these means that our end weight was in fact lower than the start weight. So it looks like that this diet has had a significant effect in helping those people to lose weight.